Okay, so this is part 3 of 5-5, and we're going to finish up these last few examples. So here we have sine x minus cosine x equals 1. Now, there's not a lot of options we have here with this equation. Things are not squared, there's not a whole lot we can do, and so we have to resort to squaring both sides of our equation. Now, the reason why we try to avoid doing this is because what happens when we square both sides of our equation is we get more answers than what actually works with the original equation. So we're going to go ahead and solve this and square this, and then what we're going to have to do is we're going to have to check our answers. So we're just going to make a note about this now. So when we square both sides of, I'll zoom out here for you, both sides of our equation, we are creating answers that aren't really there. Okay, so we have to check our answers. Okay, so we have to check these answers, so we're going to go ahead and continue with this process that we've started here. So squaring both sides, we get 1 on the left side, or on the right side, and on the left side, we're going to get sine squared x plus cosine squared x plus, or I'm sorry, minus minus 2 sine x cosine x. Okay, sorry, I had to squeeze that in there. So we know that this is equal to 1, so we can replace that. So we have 1 plus, or again, minus 2 sine x cosine x equals 1. And I can subtract 1 from both sides. And I'm going to divide by a negative. In fact, actually, I'm going to divide by negative 2. So we have sine x cosine x equals 0. Because this is equal to 0, and this is technically factored here, we can do sine x equals 0 and cosine x equals 0. Okay. So plugging in, or sine x equals 0, that happens at x equals 0 and x equals pi. And cosine equals 0 at x equals pi over 2 and x equals 3 pi over 2. So there are our 4 answers. But again, we have to check our work with these problems. So I'm going to check x equals 0. I'm going to check x equals pi over 2. I'm going to check x equals pi and x equals 3 pi over 2. Okay. So checking these, what that really means is plugging it into the original equation here. So our original equation, as we saw above here, was sine x minus cosine x equals 1. So sine of 0 minus cosine of 0 equals 1, and we're checking, is this true? I'm going to set this up for all of these first. So sine, sine, sine. Me personally, I just like to have these all set up at the beginning and plug things in. So we have pi over 2, pi over 2, pi, pi, 3 pi over 2, and 3 pi over 2. And so now what we're checking here is, well, sine of 0 is 0 minus cosine of 0, which is 1, and that equals 1. Negative 1 does not equal 1, so this is false. Here, sine of pi over 2 is 0, or I'm sorry, is 1, minus cosine of pi over 2 is 0, and that equals 1, and that is true. And then here we have sine of pi, which is 0, minus negative 1 is 1, and that's true. And Sine of 3 pi over 2 is negative 1 minus 0 equals 1, and that's false. So what that means is that we have the true ones, x equals pi over 2 and x equals pi. Those are our answers. Now, it did not tell us from 0 to 2 pi, so what we need to do here is we need to write actually that we have x equals pi over 2 and x equals pi plus 2 pi n plus 2 pi n, and that is our answer. So I know this is a long one. I'll give you a second to kind of take a look at it and kind of process it, and then we'll move on to the next example. Okay. So let's go ahead and move on now. So we've got a couple examples here, and these you're going to need your calculator for. So I'm going to zoom in again, and we are talking 0 to 2 pi again. So it says round to 4 decimal places, and we're given this equation. So what we need to do here is use our calculator, and this value right here, there's no degree or anything like that. What we're going to do then is use inverse tangent. So on our calculator, we'll do inverse tangent of 12.8044. So I'm going to go ahead and type that into my calculator. Inverse tangent of 12.8044. And I get an answer, and mine is in degrees. We want to do this in radians. And so in radians, that would be 1.4929. Okay, so I'm going to go ahead and write that. So we have x equals 1.4929, and this should actually be a squiggly because it's a rounded answer. And let's think about what this actually means in terms of your answer. This is in radians. That means it's an angle. Well, remember, this is 0, and this is pi over 2, which would be 1.57 if we multiply that out. 3.14 pi, and then we have 4.71, 3 pi over 2, and then 6.28. Okay. Well, 1.49, that's going to be in quadrant 1. Now, we got a positive, or we have a positive number here, but we know tangent is also positive over here. So what we can do is we can add 180 degrees, or in other words, pi, and that'll give us our other one, our other answer between 0 and 2 pi. So x equals 1.4929 plus pi gives us x equals, and pi, remember, is 3.14. So this will be 4.6344. So we have two answers between 0 and 2 pi. Okay. Let's go ahead and look at the next one. Cosine. So we want to think here, okay, well, cosine is negative in quadrant 2 and in quadrant 3. So we know our answer to this is going to be in those quadrants. And we have x equals inverse cosine of negative 0.4317. And when we plug that in our calculator, that gives us 2.0172. So there's one of our answers. And if we think about these quadrants here, remember 1.57, 3.14, 4.71, that means this one is in quadrant 2. So this is the x that we just found. But we need to find the same one in this quadrant. Well, we want to have the same x value here. And so what we can do is this distance right here, this reference angle, we can find that. So this would be 3.14 minus 2.0172. And so what we can do then is find what that is. And that gives us, let's see, 3.14, 2.0172, 1.1228. So this is 1.228, 1.1. 228. And what that means is we want to go the same amount this way. So to find this angle right here, we would find 3.14 plus 1.1228. So plus 3.14. And we get 4.2628. So that's our other x. Okay. And so that's how we can find those angles. Okay. And we have one more example left on the next page. So let's go ahead and get to that. All right. So we're going to go ahead and solve this. And tells us right off the bat we're going to round to 4 decimal places, so that tells me we need our calculator. We have sine squared x minus sine x minus 1. If I do a u substitution, that's going to be u squared minus u minus 1 equals 0, and that's something that we need the quadratic formula for. That's not something that we can factor. So u equals, and our b is -1, so 1 plus or minus 1 minus 4 times 1 times -1 over 2 times 1. So 1 plus or minus the square root of 5 over 2, which is about 1.618 and -0.618. Okay. Well, what that really means is u equals 1.618 and u equals -0.618. And u really represents sine. Remember, u equals sine x. So sine x equals 1.618 and sine x equals 1.618. Oops. And we know that there's no solutions from this factor because sine's never bigger than 1. But we can get solutions from this one. So inverse sine of -0.618 is going to give us -0.666. But we're talking about from 0 to 2 pi. -0.666 is going to be right about here. So we want to find out what is that angle in a positive angle. So this is -0.666. And sine is negative here, and it's also negative here, so we're going to go down -0.666 here and find out what those angles are. Now, this is 3.14, so 3.14 plus 0.666 will give us 1x. And the other one, we would do, it's just shy of 2 pi, so remember 2 pi is 6.28. So 6.28 minus 0.666 is going to give us the other x. So let's go ahead and calculate those, and we get x is about 3.8078 and x is about 5.6170. And those are our solutions to this example. Okay, so that brings us to the end of section 5, and that finishes chapter 5.